Yeah, good morning to all. So coming for the continuation of the third topic in CO-1. So what are the different design considerations that we have to keep in mind while designing the flat slab? The first one is the wall and column position. So locate the position of the wall to maximize the structural stiffness for lateral loads, and it facilitates the rigidity to be located to the center of the building. And you can see the typical floor plan where the yellow colors are indicating the column positions. So coming for next one is the optimization of structural layout plan. So the size of vertical and structural members can be optimized to keep the volume of the concrete for the entire superstructure inclusive of walls and lift cores to be in the region of 0.4 to 0.5 meter cube per square meter. So this figure is considered to be economical and comparable to an optimum design in conventional of beam and slab systems. So coming for the next one is the deflection check. So it is necessary to include checking of the slab deflections for all load cases, both for short and long term basis. In general, under full service load, deflection should be less than L by 250 or 40 mm, whichever is smaller. So limit set to prevent unsightly occurrence of cracks on non-structural walls and floor finishes. Next one is about the crack control. Advisable to perform crack width calculations based on spacing of reinforcement as detailed and the moment envelope obtained from the structural analysis. So good detailing of the reinforcement will restrict the crack width to within acceptable tolerances as specified in the codes, and it will reduce the future maintenance cost of the building. Next one is about the floor openings. So no opening should encroach upon a column head or a drop. Sufficient reinforcement must be provided to take care of the stress concentration while giving the floor openings. And so coming for the next one is the construction loads. So critical for fast track projects where removal of forms at early stage is required. Possible to achieve 70% of the specified concrete cube strength within a day or two by using high strength concrete. Alternatively, it uses two sets of formworks. Next design consideration is about the lateral stability. So buildings with flat plate design is generally less rigid. The lateral stiffness again depends largely on the configuration of lift core position, layout of the walls and columns. Next one is about the frame action is normally insufficient to resist lateral loads in high-rise buildings. It need to act in tandem with walls and lift cores to achieve the required stiffness. Next coming for is about the design methodology which we have to follow. So what are the different methods generally available in the case of flat slabs is first one is the finite element analysis, which is a widely used one, and next one is the simplified method which is given in the prescribed textbook, and next one is the equivalent frame method. So these are the general difference of methods of design which we will be going for using the design of the flat slabs. Next one coming for the finite element method. So based upon the division of the complicated structures into smaller and simpler pieces elements whose behavior can be formulated, that is called as a finite element method. So the example of that software includes softwares like SAFE, ADAPT, etc. So the results in the results, what are things that are going to include is the moment and the shear envelopes and the contour of the structural deformation we can clearly see in the case of the finite element method. And you can see here types of two-way slabs. First one is two-way slabs on you can see figure number A, two-way slabs on rigid or flexible beams. You can see here 4 columns, it is having two beams connected by four beams. And next one is the waffle slabs in which it is having a wire mesh, and next one is the flat plate which is having only slabs, and you can see next one is the flat slab which is having the column heads also. So these are the different types, and you can see here what are the different types of support for flat slabs and flat plates. First one figure is flat slab with capital, which is having at the center portion. And next one is second one is flat slab with drops and column capital. You can see here it is having drop as well as column capital, it is having both the things. And next one is the flat plate, which is directly connected on the connected to the column. And next one is slab connected onto the wall on one side, which we will be calling it as a like a cantilever slab. So these are different slab that are generally we are going to design in the case of structures. So this is about the different design considerations. Quickly I will be memorizing what are the different things that we have already seen. So coming for the design considerations, wall and column position, locate the wall and column position to maximize the structural stiffness for lateral loads. Optimization of structural layout plan in the sizes and vertical and structural members can be optimized to keep the volume of the concrete for the entire superstructure inclusive of walls and lift cores to be in the region of 0.4 to 0.5 meter cube per square meter. So this figure is considered to be economical and comparable to an optimum design in conventional of beam and slab systems. So it is necessary to include checking of the slab deflection for all load cases for short and long term basis. In general, under full service load, deflection should be less than L by 250 or 440 mm, whichever is smaller. So limit set to prevent unsightly occurrence of cracks on non-structural walls and floor finishes. Coming for the crack control, it is advisable to perform crack width calculations based on spacing of reinforcement as detailed and the moment envelope obtained from the structural analysis. So good detailing of reinforcement will restrict the crack width to within acceptable tolerances as specified in the codes, and it reduces further maintenance cost of the building. And coming for the floor openings, no opening should encroach upon a column, head or a drop. Sufficient reinforcement must be provided to take care of the stress concentration. The next one is about the construction loads. Critical for fast track projects where removal of forms at early stage is required. Possible to achieve 70% of specified concrete cube strength within a day or two by usage of high strength concrete. It alternatively uses two sets of formwork for taking out the loads. Next one is about the lateral stability. So building with flat plate designs is generally less rigid. Lateral stiffness depends largely on the configuration of lift core position, layout of walls and columns. The frame action is normally insufficient to restrict lateral loads in high-rise buildings. It need to act in tandem with walls and lift cores to achieve the required stiffness. So coming what is the different design methodology that we will be following. So the coming for the different methods of design is, first one is the finite element analysis, next one is the simplified method, and the third one is the equivalent frame method. So these are different three methods which we can use. And next one is the finite element method based upon the division of complicated structures into smaller and simpler pieces elements whose behavior can be formatted. Example of softwares, it includes SAFE and ADAPT, etc. So the results included moments and shear envelopes, contour of structural deformation. So coming for what are the different types of two-way slabs. First one is two-way slab on rigid or flexible beams connected with beams. Second one is the waffle slabs, and third one is the flat plate which is directly supported on only just the columns. Next one is the flat slab with cover. And next coming for the different types of support for flat slabs and flat plates. First one is flat slab with capital, and next one is flat slab with drops and column capital. Next one is the flat plate. Next one is the slab supported on the wall. Okay, with this I am closing the third chapter in CO1. Thank you all.